Hello, hello, and welcome to another how-to video in SOLIDWORKS Electrical. This one is all about 2D cabinet layouts. Important thing when we're going to, build a control system is to actually build the control system. So that's sort of the blueprint for how the physical pieces go together. Um, Admittedly, before we actually get into drawing the 2D layout, there are some sort of setup tips and tricks that we need to do in order to make it work. And one of which I haven't talked about in a video yet is locations in SOLIDWORKS Electrical. That's going to be a big one for us when we're doing our layout. It's also very useful in the schematics themselves. Admittedly, as of recording this so far, there hasn't been a big need to do locations because the sort of demonstration projects I've been working on have been fairly simple. And then we will also need to modify our bill of materials and how it puts it together, and I will walk through that as well, sort of before we get to drawing. The actual layout is relatively straightforward. It's just a matter of sort of having things set up preemptively before we jump in and just start drawing. So to do this sort of how-to guide, I did a live stream actually a few days ago where I sort of walked through the midterm that I use for this course, the midterm project. It's a sheet set for a machine that does some conveyor packing, some part packing, stuff like that. So we've got motors, we've got relays. It's a fairly simple machine, not a lot going on. There's a PLC. This particular project is not completely finished because of proxies and whatnot. I just didn't drop things in solenoids as well. But we've got I walked through how to generate the bill of materials, get it organized, that kind of thing. So this is the project we're going to use because it is complete enough to get us a pretty decent 2D cabinet layout. So I'm going to go ahead and close most of my drawings. Now, let's close most of the drawings and let's take a peek. We can start at the main power. Let's take a peek at SOLIDWORKS locations. So locations, they're going to be huge for our layout because of the way the layout sort of functions. And all of this is building I'm struggling with good ways to describe it without actually walking through it ahead of time. But so when we get into the 2D layout, we can only insert a 2D footprint for a part that exists. Well, actually, I take that back. It doesn't have to exist already, but we can only insert a part one time, a 2D footprint one time. It'll only let us. And in fact, I should be able to do that. Let's do that. And so first of all, to generate a 2D layout, it's sort of separate from reports. It's separate from I can't insert a 2D layout. There's nothing here to do it on the insert menu. But if I go to my process and do 2D cabinet layout here on the ribbon, now I've already got two locations in here. And we'll see in a minute when I start to add a location or two that we'll get more in the list. But with these checked, it's going to give me two drawings to play with right here. Now, just out of being picky, I like them to be before my bill of materials. I like my bill of materials to be last. That's me being picky. So let's sort of just pick one, main electrical closet, and make sure it's got the right. All right. So this, if we double check title block, it should be the B size without scale. And we get a list when we're in this cabinet layout of all of the parts that exist so far in our project. We can add parts here directly, and we will. For instance, things like the actual cabinet, the box, is not going to show up in this list because it's not in an electrical schematic. And that makes sense because it's not an electrical part. It's a box. So, I mean, in a nutshell, inserting, if we wanted to do a quick layout, let's say that we didn't care about the whole box, and right now all I wanted to do was the PLC. So I would, over here on the list, this is my PLC. I would click this guy. I've got a Compact Logix. Let's see which one's which. So this is the screw terminal we added for the power terminal, and we've got the actual PLC. We can leave this power terminal off because, frankly, it doesn't exist in a 2D layout. It doesn't matter. It'll show up. It'll be fine. I don't believe when I created this, though, that I downloaded the proper 2D footprint. So let's see. I'm going to check this, which will let me then insert it. Oh, I did. I downloaded the symbol. Cool. I'm going to just, drop it in there. And since I created the manufacturer part, well, first, let's change our drawing to be 1:1. So I can right click, go to properties, and the scale is right here. Right. I recommend always starting your 2D layout in 1:1, even if, like, as this gets full, imagine this is an 11 by 17 sheet of paper. And if we're dealing with a 24-inch cabinet, right, we'll be out here. And that's still how I recommend doing it. And then scaling after. Some of the tools in these 2D layouts get kind of weird. Get kind of weird if we work originally at lower scales. So I recommend doing it at 1:1 and then just changing the scale and letting everything shrink. That's how I recommend doing it. But we've got our PLC in there. I can then go back over to the tab with the actual cabinet layout parts. We don't need the power terminals. They will still show up on the bill of materials. That's where we really need them. Same for these power terminals. We don't really need those, but we do need the input card, right? And I can tell right now that something about the scaling is off. That card is not that wide relative to the PLC. So that'll be in our manufacturer part where we define the width of the card. Something about that's not right. But the thing to pay attention to is the snap to. Like I set the insert at the corner of this little plastic tab, and I've got, once I start to drag, I can snap to any element of the PLC itself. And actually, I'm going to turn off grid snap for a minute. Turn snap off. There we go. It'll still snap to the component, but it won't snap to my page now. It's a free floating. So I can line that up somewhere in there, which is where those tabs go. Click, and it drops that in. So now that's in there. Notice though, like I had mentioned in the previous video where I created this 2D footprint, it's a bounding box. So notice I lost parts of my PLC because the box that defines this part overlaps it. So to fix that, we can, like in a sort of drawing sense, we can order things. We can send things below. We can raise above. Actually, that is up here. I was looking for it in a right-click menu. It's not. It should be. It used to be. Anyway, order up here. I can, move below, and it'll ask me to select what. So now the PLC popped up on top, and I lose part of my input card that way because, again, bounding box, but it looks a little better because I've got those locking tabs visible. It just looks, slightly better. It'll never be absolutely perfect using this method, and that's okay. But then I can do the same thing with the output card, and that one pops in wide too. I'm gonna double check here in just a second our widths because I don't like that popped in sort of double wide. And let's do order and drop this below the first card just for move below that there, just so we see those clips. That looks kind of good. I can select everything now, and I can drag it. It takes it a minute. We're moving a lot of detail here. So I'm actually holding the mouse button and dragging. It's just taking my laptop a minute to catch up with what I want it to do. This is not a super awesome rig for CAD work. There we go. See, then I can drag it wherever I want. I could have turned the snap back on if I want to get precise with my positioning. I can also do things like symbol and update, and that should change things. Well, maybe not. The text looks like it's already scaled properly, but we can see our data that we created in a previous video. Everything's here. This isn't. Oh, there we go. So this is telling me the IB16, and also included here, because I made it a compound part, is the screw terminal, right? Even though I didn't drop the symbol in, it's there. And I can tell right now that those widths are not right. So before we go on, I am going to double check my manufacturer part manager, and we want PLCs and we want input cards. Actually, we can just go to IO modules. Scroll down to the 5069. It just bothers me that those are so wide. I know, just having used those for so long, they should be a lot narrower than that, about half. You see 57, so something's not right. One slot, so that's how wide they are. Like if we were to use SOLIDWORKS Electrical's automatic sort of scaling with PLCs, like the PLC tool has a lot of cool automatic things it can do. That's where the slot would come in. If it takes up two slots, it would automatically make it two widths wide. I'm not sure why at 57 millimeters it's showing up. That's almost, so this is basically 2 inches. Is that right? 2 inches seems excessive for those cards. They are very narrow. I'm going to leave them for now, knowing that, like I said, and even things like the lettering you can tell are stretched because it's scaled up the symbol that we drew. It should appear. If I go to the 2D footprint, I'll show you what I mean. Because we drew this when I created it in a previous video, we drew it to scale. This guy. This is how wide it should appear, right? This is to scale. Why it is so stretched, I do not know. But we'll leave it because that's a little beyond the scope of what I want to get into. But that's the thing to double check is to make sure because things are automatically scaled on our 2D footprints as we create these, we want to be at, and we can also tell like these clips should be the same size. We want things to be scaled properly because we're going to be dimensioning this thing and telling our technicians that are building it or even ourselves down the road, right? We got to remember, but we're going to be putting dimensions on this. And if this is way off, it's going to throw everything else down the chain off. For now, I'm going to leave it alone, but that's a thing I'll need to double check why that's so big. So typically, this is a thing that we would do. Create like a close up PLC rack so that we show clearly on a drawing where things are, like like what order to put the cards in, right? Because that may get lost in the shuffle on a busy cabinet layout. The problem, the difficulty that we have is if I switch over to the other 2D footprint that was inserted, right, and expand, I can no longer. These are gray. I can no longer right put these in. 2D footprint is already inserted, so I can only put things in once. That is a drawback. That is a drawback of the 2D footprint sort of creation tool. So we can only insert things once. That leads to a problem in that a lot of times we have holes, say, on multiple sides of an electrical cabinet. And for instance, on the front, we might have a hole that we need to cut in and dimension to where to cut it in for the disconnect. And then on the side, we may have a hole that we need to cut for cable entry. It's a problem because I can only put one cabinet in. So that's what's going to lead. I'm going to delete this because I'm just going to do a full layout. I'm not going to do an individual PLC. That leads into um, that leads into um, phantom parts. I was searching for the right words. That leads into phantom parts. Um, and the best way to sort of illustrate that first is I'm going to go out and grab a cabinet. And I've got them open here somewhere, Saginaw Controls, because, I mean, made in Michigan, right? Buy local. Wall mount enclosure, probably. They've got a ton of stuff. The cool part for me over the years has been they actually put pricing on their website, but usually, I don't want to say always, usually what you will find is the price on the website when they actually quote it is significantly cheaper in the quote than it is on the website. So if you use the website price in, say, an estimate and the quote comes back less, you automatically look like a rock star because there's already a line savings on your budget, right? So they also by default come in two colors, standard ANSI, and then this is the ISO standard. It's a little lighter gray if you're working in ISO. Um, I'm going to grab, and typically a 24 by 24 is sort of my go-to for a generic cabinet. That, I mean, you can fit an awful lot of machine in a 24 by 24 cabinet, and probably 8 inches. So I'm going through. I'm just grabbing. You can download a full CAD package, which is what I'm here for. That's literally why I opened their website. I need the CAD package. I'm going to open it and extract. Oh, I'm sharing an application so you can actually see me extract. And you can actually see probably my Windows Explorer. But when I download it, I got now IGES files. I've got step files. So I could open it in SolidWorks if I want. There's a PDF. What I want, there's a DWG. That's what I need for SolidWorks Electrical. So let's go back to SolidWorks Electrical and file, open it's in my downloads, not my documents. SCE, the drawing. So there is the drawing of the cabinet. And I'm not going to, I think I deleted things when I demonstrated creating the PLC footprint in this method, opening their drawing from Rockwell. I think I ended up deleting like the other views. I'm not going to do that here because I am going to end up wanting all of these other views. So I'm going to, for now, leave it there, but I need to create library symbol management. I need to create a new 2D footprint for that box. So I'm going to, in boxes and cabinets, enclosures, and there are a lot of things here, right? I'm going to put it here. It's an 8-inch box. Height less than 2. No. Let's go here, 40. I mean, you can arrange things the way you want, obviously, but I like to be complete if I can. So we'll create a new one. I like to put everything in user. The title. Now, when it comes to cabinets, because the 2D layout automatically scales, um, because the 2D layout automatically scales, and did I share that app? I should share the whole window. Let us stop screen share. Hi, welcome to full screen. Let us stop. Let us share the entire window. Share. That should be a little better. So, because SolidWorks Electrical scales automatically, if we were to say use this same footprint that I'm about to create, if we were to use that for a 36 by 24 cabinet, everything would be skewed. Holes wouldn't be round anymore, things like that. So in the case of 2D footprints, I make a unique footprint for every part. Every cabinet at least. Things like relays and stuff really don't matter. They can become somewhat generic, but I mean, this is sort of the star of the show, the cabinet, right? So this one I'm actually going to use Saginaw's part number to name it, because it is not going to be reused for any other part number the way that the IO card footprint, for example, was. That can be any IO card. This is a 24 by 24 by 8. 24, whoops, 24 by 24 by 8 enclosure. Let's see, we already did user manufacturer. Probably doesn't exist. I do want to add this information because once I get it into my 2D footprint, it's now going to be on the bill of materials. So manufacturer is Saginaw, and I always call them electric. I believe it's officially Saginaw Controls. Saginaw, let's be official, control and engineering. And then the reference is this part number. And that doesn't actually exist as a part yet, but Mark Root, I mean, they don't really, I don't label the cabinets usually, but I suppose we could call it cab. I don't usually label them. No cross references because it won't show up anywhere else. Connection points are fine. There's not going to be any circuits. That just is circuits. So we can do that. Okay. Open it up. And I'm going to, whoop, not Alt Tab. I want this drawing and I just want to copy this sort of center view. So Control C and keep Alt tabbing to switch tabs inside. Control V. Again, as in the previous video, notice how tiny it comes in, like absolutely minuscule. I'm going to delete the dimensions because I don't need them. Delete that little front view text. I'm going to grab this and I'm going to move it. It doesn't really matter on the insertion point on the cabinet much, but I'm going to move it so that this sort of this panel mounting hole here is on 0. So I'm going to modify move. And I promise all of this, I need to turn the snap off. There we go. So I'm going to grab the center of that hole, and that's where I want 0. 0. So we're good. We've got that in there. Now, this thing is tiny. We need to rescale. So I'm going to select it all. I'm going to modify scale. And I will almost guarantee you for before I scale it, I will almost guarantee that it's a metric conversion like it probably came in at 24 millimeters, not 24 inches. So if I do that, that's 24 millimeters. Um, so we're going to scale it all up by 25.4. It's a pretty easy scale so that it's sort of true to size. 25. Ooh, enter coordinates, not 0, 0. There we go. About the origin, enlarge 25.4 times. That'll get us back up to true dimensions. It got way bigger. You can tell that by the way I zoomed it out. Now, I don't generally put a tag on it. I suppose I could, but you do put the part number. So let's do a tag and let's do a manufacturer part reference and do that way. Now, notice how little my text is. That will show up that size when we put it in the drawing. So we do want it bigger. Height. Ooh, at that size, probably, so we can read it at least like 5. If I zoom way out, maybe even bigger than that. What do we got with 10? That'll work. So with 2D layouts, because again, so tag, because again, um, in the 2D layout, everything is automatically scaled. The text will be automatically scaled as well. So make it look good here, and it will show up good even if it's scaled. You might have to do a symbol refresh to get it to resize the text appropriately, but that looks good there. That's really all I throw in here. This is finished. I mean, so we can now save that, close out of it, close out of it. Now I have to create the part. Ooh, I don't want to close that one yet. We do have to create the part. So manufacturer part management, boxes and cabinets, and that part should not exist. Oh, it does. Nope, that's a push button in a different Saginaw. I wonder if I could have downloaded their whole catalog the way I did. Anyway, the way I did before. Enclosures, we threw it in less than 40. We need to create a manufacturer part reference. I don't have it copied anymore. Copy, paste, manufacturer, grab it from here because they should exist now. No? Huh. Okay. Saginaw, control, and engineering. Boxes, cabinets. Again, I like user for everything I create. None of that matters. This is a 24 by 24 by 8 enclosure. Supplier name. Now it should appear in the... No, no, it doesn't. Wow. Saginaw, control, and engineering. Stock number still copied. Good. So there is no line diagram for this guy. There is no schematic because it's not electrical. I could do a 3D part. I didn't. The 2D footprint is going to be the one that we just created. Ooh, why did it not save my... Did we botch something? I'm going to go ahead and create this because there's no reason to delete that. I'm going to go back and did I botch something during my creation? Did I botch something during my creation? 2D footprint management. Boxes, cabinets, enclosures, less than 40. Did I create it as a symbol? I did. We need to change the properties. You are not a multi-wire symbol. You are a cabinet layout footprint. It will be stored in the footprint management, so it will move it. Okay. And it disappeared. Awesome. So I just selected the wrong thing here. It's that easy to move. I just selected the wrong thing here when I created it. So now, when I go back to my part, the one that I just created, I should be able to assign it as the footprint. 2D footprint. There it is. So we'll assign it there. Height, width, and depth are important. Height, width, and depth are very important. So we need, I don't know if those are true dimensions or not. The best way to get height, width, and depth is actually off of their drawing. It is 24, truly 24. It is, I need a view of that. It is truly 24, and those are the proudest things. Like it doesn't extend beyond that 24-inch box. So it is truly 24 by 24. What is the depth? All right. And depth is important, including the door. So this is not 8, it's 8 excluding the extra inch or so we get from the door. But remember, it'll be automatically scaled, and that scaling will include the door. So I need a clean dimension for that 8 inches. And let's just drop one in here and see. Again, high point to high point, 9.128 is going to be good enough. I'm going to do a quick metric conversion on my calculator because I'm not going to convert that in my head. 9.128, 25.4. Helps if you multiply and not divide. 231.851 millimeters. Not Alt Tab. We need library. We need to go back to our manufacturer part. So it is a true 24 by 24. Let's see. Depth was the one I just calculated, right? 231.851. 231.851. 24 inches times 25.4, 609. 609, any decimals? 0.6. Okay. 609.6. Right, and that's really all we need, height, width, depth. We could throw a weight in there. Do they give us a weight? I mean, that would be kind of cool. I've never done it before. 48 pounds, that's a close enough estimate. Weight in kilograms. 2.2 is the conversion, right? Let's see. 28 pounds, 2 kilograms. Yeah, right about. So 12.7. 12.7, right about. Okay, we're good. We got kilograms. I've never done the kilograms before. IP protection, that's kind of cool. I usually don't put that in there either. I believe it's an IP4. Or it's not, well, probably not an IP4. It's probably listed as NEMA. Let's see, options, IP66 right there. So NEMA 3R. NEMA 4. Ooh, cool. IP66. And actually, that's a text field, so I'm going to put the IP in there. Because that would also, I mean, make sense to put on our, I didn't because I never thought of it, honestly, until filming this live. I've never thought to put the IP protection or the NEMA rating on the schematic, but that's actually not a bad idea. The more information I can give to somebody, like if I'm a lot of times what happens, especially in the machine build industry, is an electrician will be doing this sheet set and then handing it off to somebody to build, to put together. And the more information you can give those people putting it together because they weren't actually in on the design, the better. So the more I can put in these fields, the more. Oh, and I forgot my 2D footprint. That was the whole point of moving it right there. All right. So we're good. We're good. We've got that. Now, I had started to talk about phantom parts, or I mean, the end result is going to be phantom parts. If we have things that we need to mount on the side of this box, I can't. I've demonstrated with the PLC. I can't put this box in more than once. Right now, this part is going to be a front view in a 2D layout, and I can put a cutout in the front for buttons, for disconnects, for HMIs, anything I want. But if I have cable entry or buttons or lights or anything on the sides, I can't put another view of this part in there. It'll only let me insert it once. The workaround around that is to create a phantom version of this part. And I'm going to walk through sort of what that means. So we're going to go properties. And I did it on purpose. I had that selected because we don't have to recreate. If you have a part selected when you create a new one, you don't have to populate, like all these fields come in the same as the one you had clicked on, right? So all of these are still the same. I'm going to change the reference to Phantom. Actually, I don't want to change that to Phantom. Let's call it cable entry. Usually I try to come in from the left. Let's call it left side. And then when I create the 2D footprint, which I'm going to, actually, I don't have to change it yet. I will change it. Left side view. All right. Stock number, whatever. Yes, good. Dimensions. Now change. Important. Now change. So the width becomes the depth, or and vice versa, because I'm going to be doing it from the side. 0.6. Weight doesn't change. I will change this in just a moment, but for now I'm going to accept that. Oh, I'm going to just get rid of this stock number. One other thing, the whole phantom part. I'm going to make use of my user data here. User data 1, I am going to put the word phantom in there, and that's on purpose. So that's it, just calling it phantom. And then okay, and it should like it. So now I have, make that a little bigger so you can read it, a left side view. I need to now create a 2D footprint for that. And again, if I select this, I should be able to create a new one with most of that populated. Nope. Okay. It is going to be this part number, so let's grab that again. And again, I'm going to call it left side. Why did that zoom in? No, copy, not zoom. And left, oops, left, left side. Thank you. 24 by 24 by 8 enclosure left side view. I must be having a low dexterity typing day. User objects, manufacturer, Saginaw control. I'm going to leave the rest alone. Okay. And I'm going to edit it. And now I'm going to grab the left side, which should be this view. Oops, I grabbed part of the title block. That side. Copy. Paste. Again, it comes in tiny. We'll fix that in a minute. We're going to get rid of the labels and the dimension. You could also color these green, like it's line colors and stuff here. You could just it doesn't really matter to me much when I do it. So I'm going to first move, and turn my snap off again because the grid snap gets annoying. It does get very annoying with 2D layouts. So I end up turning the snap off a lot. Object snap is usually okay. Let's go to 0, 0, but I turn the grid snap off because it gets in the way a lot. Grab all of that, scale it up about the origin. Whoops, 0, 0. Enlarge it by 25.4. Okay. And we're going to Control S, save that. No markings on this one. No markings because as far as SolidWorks is concerned, these are going to be two different parts. We're sort of cheating it, and I don't need that anymore. We're sort of cheating it into believing that there are two different parts. So to get it in there, right, to get it in our cabinet layout, I need the cabinet layout tab, which I only get when I have the cabinet layout open. I'm going to insert a 2D footprint. Oh, I need to, sorry, add a cabinet. This is how we get extra parts in. You must select a location, of course. So here, fine. Select it in the list and then add a cabinet. Boxes, cabinets, I don't remember if I called it a base. I think I did. I did. So I'm going to include this one. Select. All right. Again, scale in the drawings 1:1. So this box is way bigger than the sheet, which is fine. Again, I draw it, I create it at 1:1, and then go about my business of drawing it and then scale everything at the end. Right. But again, our text scaled properly. Then I'm going to do this same thing, add a cabinet. And this is how we get parts in that aren't necessarily on our electrical schematics, right? I'm going to drop in a left side view of this guy, and it's scaled. Oh, I'm sorry, I never changed that part. Let's change the manufacturer part first. I got to tell it to use the right, I got to tell it to use the right 2D footprint, the side view. It scaled it correctly, but I got to tell it to use the right drawing. This drawing. Thank you. Okay, close. Now we can cabinet layout, add a cabinet, and scroll down and grab the left side view. There we go. Right. So we've got the two views. They now show up here. Do they? Yes, because I added them. Why we've got two? Oh, parts are persistent. Important to note. In 2D layouts, if I just delete it like I did, it stays here. So on my bill of materials, I will get two. we want to delete. You want to make sure you delete them if you truly don't need them after you insert them. But insert as a cabinet. Boom. Right? There we go. Now we have an issue, and I'm gonna divert from the actual 2D layout for a minute to talk about the phantom thing as far as the bill of materials is concerned. So if I go back to process and I go project and my reports, and I'm just going to generate drawings. I'm going to update my bill of material to basically include the box that I just dropped in. Close, close, and now if I go to my bill of material, I got to find Saginaw Electric, which should come after R, right? Hopefully, Saginaw Control. It shows me, right, the LP and the LP left side. That's no good. I don't have two boxes. I've got one box with two different views. What I can do, the fix, the sort of workaround around that limitation, I am allowed to filter my bill of materials. I can filter it on just about any criteria I can create. None of the default ones, like you can play around with these default ones. None of the default ones will actually do what I need it to do, but I can add them and I can create my own, which is cool. So I'm going to call it Phantom. Filter out Phantom parts. Okay. And then I'm going to add a new condition. I don't really need an and field though. All these are all the fields that it can grab and filter on. I used user data 1. I believe it was, let's make sure there's not another user data. Sometimes that can get tricky. That's what I used though. So user data 1. We're going to use not equal phantom. I'm going to get rid of that. We don't need an and. Just that. User data 1 not equal phantom. And that should work. I'm going to now generate my drawings. I'm going to select this. Then it shows up as a separate drawing now. Boom. Get rid of this original bill of material and select my new one. Okay. So it's effectively the same BOM. It is just now, now the drawback is, notice the original stays because it sees it as a new drawing. But if I go here, first page didn't change. Second page, the left side disappeared because I put the word phantom in the user data and then filtered it out. I said, only give me parts that don't have phantom. So that is a way that we can sort of cheat things like the view limitation on 2D footprints. So I'm also now going to delete these two drawings since they don't exist anymore, right? I'm not going to use the original 7 and 8. Pages 7 and 8 were the original bill of materials. I'm not going to use those. I'm going to use the filtered one from now on. From now on, I'm using the filtered one. So back to our 2D footprint. All right, we got the cabinet in. Everybody's happy. In this case, we do have a disconnect. So let's go ahead. I can use this as sort of a demo for the first part of creating an actual 2D footprint. So the disconnect main circuit breaker, let's treat that. I don't know for sure, but let's treat that as if it were an actual disconnect on the door. Which is a problem because it doesn't actually have any dimensions defined. So we're going to get like a generic. I mean, it'll work, but we're gonna get kind of a generic look, right? It's not, yeah, yeah. What about switches? I'm looking. I don't want to. There. That looks like a rotary door switch, and this is just default dimensions because the part number tied to this right now doesn't have any dimensions in it. So I'm happy with that for now. I mean, I'm going to, if I were doing this, for a full project, I would make sure this part had actual dimensions so the scale was right. But the disconnect usually goes somewhere in here, right? And then, I mean, to dimension the guy, we need to tell somebody where to put it. Uh, on our drawing, we have the dimensioning tools just from like AutoCAD type stuff. So, I mean, grab an edge and what do we dimension from? Probably, I mean, my object snap should be on. The grid snap's off. There. there. You can also, I mean, in fairness, can also place it far more precisely. So let's do that. Let's delete, because 3.06, I mean, let's face it, no cabinet builder in his right mind is going to grab 3.06. Um, Switches, grab our thing again. So as far as placement goes, drop it in. I can also do the modify move. I've got the full suite of tools because this is a CAD drawing now, not an electrical schematic. I got the full suite of drawing tools. I can move that symbol. The base, let's do it off the center. And we should be able to do relative. But I mean, in fairness, you can place the other trick, the trick that I've used a lot. Let us say, I have no idea. That's 3 inches to the middle. I'm going to move this, get it out of the way. The other trick, we can also use construction, right? Standard CAD, excuse me, standard CAD sort of process. We can use construction. So if I draw a line and let's say I want it, I don't know, 3 inches from the wall, right? This is what somebody's going to measure from a corner of the cabinet, probably, maybe even a corner of the door. So let's use the door. The door might even be better because you stick a tape measure right on there, right? Um, Trying to make it as easy for the cabinet builder as possible. So I want that to be at -3 comma 0. So that's 3 inches long now, right? It's this line that's stuck is 3 inches long, and I can come down now at 0 comma -3. Okay. And now it's 3 inches in, 3 inches down. That's nowhere near enough for this switch, right? It's going to hit stuff, but you get the idea. Modify move. Now I can move the switch, and I've got all kinds of snap. Well, I was going to the corner, wasn't I? I've got all kinds of snap twos I can use once I'm in move. So move, I can grab that corner the way I wanted it and snap it. Turn this. Why are you only? Oh, move will only allow me to move in one dimension. That kind of sucks. But if we get close, if we snap here and then move it again, I thought it used to let me move it in two. Oh well. And we could just sort of snap it to the end of that line. Now that corner is 3 inches in and 3 inches down. So that's how we're going to ultimately maneuver everything we create. And I could delete the construction lines because I don't need them anymore. That's ultimately how we're going to maneuver and get things exactly where we want them in our layout. So here, now I can insert an actual dimension here and an actual dimension here. I don't know why that didn't extend all the way down there. That's odd. Anyway, now that let's say this is complete, I mean, I drew this in here. I could also do the cutouts for like wire entry and stuff the same way. I drew this in here mostly to demonstrate how to get a second view in. Um, but we're sort of complete on this drawing, so I would new, um, not a new. We want to edit the properties. Sorry, I was thinking 3 steps ahead and got lost a little bit. I mean, I recommend stepping the scale down, but let's try a quarter scale first. So everything's scaled down to a quarter because the dimensions were already in there. Once it's like old school AutoCAD rules. Once the dimensions are in there, they are just drawing objects. They are not going to update sort of intelligently. So scaling did not change the fact that it thinks those are 3 inches because they're kind of dumb now once they're in. The reason I recommend doing it in 1-to-1 is if I were to dimension it now, let's do a linear dimension. If I'm dimensioning from that corner to this corner and doing it now, oh, it actually did scale. SolidWorks fixed it. Live video, I didn't test this ahead of time. SolidWorks fixed it. It would have given me what's a quarter of 3 inches? 1.25? No, smaller than that. 75? 0.75? It would have given me 0.75 in previous editions. So it is fixed now. Still probably a good idea to work in 1-to-1 and scale it later, but that's good to know that it's fixed. I mean, I'm not too proud to admit that that's cool. They fixed it. It's awesome. It used to be a big problem, but still, one-to-one works well. Then, yeah. So that we just created like the 2D cabinet layout. And the real meat of an electrical design is not the box, it's the back plane that fits inside the box, right? That back panel where all of our DIN rail and ductwork and stuff are mounted to. That back panel is typically a separate component. In some companies, such as Rital, they sell them together and they don't really have a separate part number for the backplane. That becomes a time where we have to bring in just the cabinet part number and then cheat with the Phantom in order to get a backplane in. Because again, if it's all one part, I can't put in a cabinet and a backplane. It doesn't work. So the Phantom trick is a key takeaway from this video. But let's now add a 2D footprint, and we have a problem again. And this is one of the things I mentioned before. Let's process 2D cabinet layout. I can't add another one, right? I've got the automatic, so this is the whole project. I've got one assigned to the whole project. I've got one assigned to this location main electrical closet. That's what this is, right? Now this I could use for the whole project, but that doesn't really tell me what's sort of going on, right? I could also, I guess, select, stuff from here. So this is where locations come in handy. They also come in handy just plain for clarity. Let's just get that straight. Again, for more information for clarity, I'm going to close all these drawings that I no longer need. And we're going to look at this as far as location is concerned. So the location in SOLIDWORKS Electrical are a way for us to break down, I'm going to go to locations, to break down exactly where components appear. So for instance, this is the whole project. There is a main electrical closet, and that's the default. I sort of hate that name. I just haven't come up with anything better. I could probably call it cabinet and make it, fit better. In fact, why don't I do that? Properties, main electrical cabinet. There. Make me feel better. But I can add locations. So this was a conveyor motor of some sort. That motor, I know as the designer, this motor is nowhere near that cabinet. It's out on a conveyor somewhere. So I can create a new location. It will be automatically given L2, location 2. It doesn't have a parent because it's not part of another cabinet. All of that's fine. And then the description, I think it was a part sort conveyor, right? Things that are going to be out on the part sort conveyor. Okay. Right? It pops up now. I have a part sort conveyor location. What I can also do is I can click main electrical cabinet, and this is what I'm going to do for the back plane. I can create new cabinet back plane. It is a parent is L1, so if I hit OK, right? L1, L1, that's key. So close. Now if I create a new 2D layout in my process, 2D cabinet layout, all right, I don't want one for the part sort conveyor. There's nothing to show electrically. The mark is what I wanted to show. L1, it automatically tells you it's part of L1. It's in the main electrical cabinet. But this location is L2. It's a new location for the backplane. And I'm going to move it up because it automatically inserts it at the end. Cabinet backplane. All right, so I can do my backplane here now, which is what I want to do. I am going to set it to 1-to-1 to start before I jump into sort of actually creating this thing. 1-to-1. 1-to-1 scale. Okay. And notice L1, L1 cabinet backplane, parent, child. And you can go deeper. It just depends on what you need to do. So that's sort of how we get, and I can also get rid of this automatic case packer because I generally don't use the top level layout. So we got a main electrical cabinet now, and we've got a cabinet backplane. Okay, we've got a cabinet backplane. So the title of this didn't change because notice this changed to cabinet. This did not change because that's part of the drawing. I have to actually change the properties and change it here to get that title block to change, which is fine. Main electrical cabinet. There we go. Everybody's happy. Okay. So we're on the back plane. We need to do the same thing that we did for the cabinet. I need a back plane. I need the plate. Saginaw Controls sells them as separate parts. And usually in here, if you scroll down, are all the accessories and things, including sub panel. That's what they call it. So we need to create a part for this. I'm going to create a manufacturer part for that. There isn't category for, you could put it, I just kind of put it in the top level of enclosures because there isn't a category in enclosures for that. So I just put it in the top level because they always go together. So add a part, the reference, the manufacturer is going to be Saginaw. Scroll down and find them. Again, I like user. You don't have to set the library datasheet marker. You can also attach cool parts. You can also attach in any manufacturer part, and I haven't gone through this before. You can attach data sheets, PDFs, which would be awesome because then it sort of embeds in your project. Description. It is a 24 by 24, and I don't want to leave it at that because if we look, that's the cabinet. These are the actual dimensions of the plane. 24 by 24, which is a back plate. And then in parentheses, usually I put the 21. 21 by 21. So 24 by 24 tells me it's going to go with a 24 by 24 cabinet. But if I grab it, and I've done this, and I'm trying to help folks maybe avoid some of the pitfalls I've run into with these videos too. If I grab it, but I've got like a 26-inch thing that needs to go on it, or a 23, say a 23-inch thing that needs to go on it, I would look at this and say, hey, it'll fit, and then have to replace it later with a bigger panel because no, it's actually 21, buddy. So that's why I name it this because it's for a 24 by 24 cabinet, but the true dimensions are 21 by 21. So that's why I sort of do it that way. Saginaw Control, their stock number is this. We haven't drawn a 2D footprint yet, but we can get dimensions in there. And again, calculator, I just put it to the side because I don't convert well in my head times. 25.4, not 24.4. That would be bad. 533.4. 533.4. 533.4. And then it's what, like 3/8? No, 7/8 times 25.4. 22.225. 22.225. Good. None of this other stuff. There is no IP protection. It's a panel. It's open to the air. There's nothing. The only thing we'll do is we'll go create a 2D footprint and then assign it in here. Come back in here and assign it. But the part exists now. Close that. Close that, and we want to go to manufacturer part management. Oh no, I'm sorry, 2D footprint. And I shouldn't have closed the. Shouldn't have closed. Let's create. Now, we could just use this. This is just a generic box, and it will automatically scale to 21 inches by 21 inches. The problem is this thing's got holes in it. Holes in it that we generally need to avoid in one way or another. This doesn't show us any holes. So I recommend grabbing their CAD package again and using their actual CAD. It seems tedious, but we're trying to be complete professional. We want this to look good when we're done. All right, we got it all. Let's go back in now and open it. Actually, I can create the new first while I'm here. There's that 24 by 24 back plate. And again, 21 by 21. All right, the manufacturer, again, Saginaw Control, the part should exist. I got to go up to, oh, it's right there. Cool, select, that's it. All of that's good. Open that, and now also open the CAD that I just downloaded. We got to go up one, 24 by 24. grab that, copy, and just paste it all over here. And again, it'll need to be scaled, and I need to delete quite a few notes because they give dimensions for all of these circles, which I don't really care about on the layout. Um, I mean, I care that they're accurate, but I don't need them labeled on my cabinet layout because, again, a panel builder is not going to care. He's going to care what the dimensions he needs to follow are. So move this guy over to the origin just like we did before. Get rid of the snap because it's getting in the way. Snap gets in the way a lot in this drawing mode. Moved it to the origin, grab the whole thing again and scale now about the origin, and we want to enlarge it 25.4. We got real huge, but that's exactly what we want. And again, I mean, we could do tags. I don't really define tags for, so I'm just going to do manufacturer part and part number. And again, they're tiny. I don't remember what I used last time. It was like 8, 10, something like that. So we got manufacturer, we got part number. Move them a little closer just for grins there. Cool. Save that. Close, close, go. No, I didn't make any changes. And then go into our part manager and add that as the default for that part. Enclosures, this guy, and that is the default 2D footprint. Whoops, clicked the wrong thing. 2D footprint, and it is that guy. Close. Now I can insert it. So on my cabinet layout tab, I can add a cabinet and scroll down, and right here, select. There it is. And again, I'm scaled 1:1. So that's sort of why it's so huge. But that's, there we go. We got our thing in, our thing. We've got our cabinet in. It shows up now here under under our parts list. Right under our parts list. So the start of this, usually these are the mounting holes, and they usually have studs in the cabinet and then nuts, flange nuts that fit on these to sort of lock it down, tie it down to the cabinet itself. So I try to avoid those with my duct. A lot of people take their duct work all the way to the edges. I try to avoid those, and I try to give it some space. So I'm going to draw a rectangle, and I'm going to snap to the center of that. And this is basically going to serve as my keep out zone. Like the duct cannot get inside of this rectangle. So we want to go relative. I don't. An inch might be excessive, but let's do it. An inch and then -1. I want it to come in. So there. So our ductwork has got to start sort of outside. Like this is a keep out zone. That's where I start all of my cabinet layouts, and I do it along every one of the mounting holes. So at, in this case, -1, -1. It's a keep out zone. Duct will run from here to here and shan't go beyond, right? Which is another reason to plan ahead for your cabinets. You're losing space by doing it this way. That I'm admitting that. In fact, that is huge. Let's do a 1/2 inch. Actually, I'm going to leave it for now. I can do it as I go. I can do it as I go. But we're we need to make sure that keep out zone's there, and probably a 1/2 inch is good, right? We just need enough room to get the nut on. So I guess then the first thing to do would be ductwork. So in our cabinet layout, next to add cabinet, which is how we got the backplane in the first place, we have add rail, we have add duct. I tend to put the duct in first, at least sort of the box. I surround it first. So if we add a duct, oh, we gotta have stuff selected. Add a duct. It needs to know where to put it. We've only got one. I have no idea what this duct is, so we'll see how it goes. I have no idea what size it is. Oh, there it is. So ductwork is sort of a floating length. So this is what's going to insert, and I'm going to demonstrate it sort of up here where it doesn't matter. I'm going to click here, and then the line, I'm not dragging, I just clicked to drop it in. You can see the length changing. You can also type in a length. But as I drag, right, it's increasing. If I click again, it chops it off. So I only have the length of ductwork that I needed. So it's like a floating variable length component. Same thing with rail when we get there. Thing is, I don't know what that part is. So I'm going to even though this is a quick tutorial, I'm going to quick create my own duct because I don't trust it. And I usually use Eboco duct. And for this, I mean, for this project, it looks like 1 inch is probably good. So 1 by 3, one height 3. And you got to be careful because sometimes the 1 inch, sometimes wide finger, that's fine. Okay, I'm going to do that. Um, we're going to use that one. So again, same process to create that library manufacturer part. In this case, it's in enclosures. Yes, ducts. We've only got two. Add a manufacturer part. It's a duct, right? I'm going to throw it in user. Reference is going to be this guy. Manufacturer is Eboco. While I'm here, stock number is the same, and Eboco I know comes from H Barnum for me at least. So description is light gray white finger duct, 1 inch wide by, grab all that. Light gray wide finger duct, 1 inch by 3 inch light gray wide finger duct. Cool, right? Line diagram. None of that stuff matters. Width and height do matter. Width and height do matter. Width, I'm going to leave that at 0. Actually, can I set it? It comes in, I think, and it doesn't actually tell me. Let's set it at 3,000 meters or 3,000 millimeters, 3 meter, 9 feet ish. Height 1 inch, 25.4. And what would that be? This 76.2. Well, live math is always dangerous. 25.4 times 3 inches, 76.2. Cool. All right, we're good. We're good there. Now we will see. I'm not 100% positive I wanted to set this at 3,000. Oh, I didn't actually. That was in the wrong spot. I put that in the wrong spot. I didn't know. I don't know if I actually wanted to set that at 3,000. We will find out in a minute. But we've got it now. It's a part. It's a part. It's in there. It's good. And actually, can I do the 2D footprint? Uh, edit properties. Where are you? Properties. 2D footprint should be cable duct. They're all generic. They're all the same from sort of no matter what the part number is. So now let's attempt and see. I don't know if I wanted to set that length. I don't remember. It's been a minute. Okay, so at a minimum, my height, width, and depth are backwards. Again, let's get that out of the way first. We can tell that by how it wants to bring this symbol in. That's cute. That looks like it's 9 feet tall. Oops. So we'll change some dimensions, but I can still drag length. That's cool. Uh, oh, that's cute. So the 1 inch, let's go checking things based on the. I mean, we can always just delete it. Again, it's going to stick, so make sure you delete it everywhere. Delete it from the list to this as well. The duct that I just played with the first time. Library manufacturer part, which we'll play with some dimensions. We'll play with some dimensions. So the 9 feet is what it was what it was saying for the height. That we want the 1 inch. The 9 feet. This might be the 9 feet. I'm not honestly sure at this moment, but let's do it. I mean, it doesn't take much to try. Cabinet layout, add duct, grab that, select. That looks better. Now, if I grab it, we can change the length, right? That looks better. So we're going to delete that. Um, we're going to delete that. And we're going to, again, we need to keep out zone. Like we need to keep out zone. So I'm going to draw, and this time I'm just going to use lines. from here, and I think a half inch is probably okay. 1 inch looked really big at 0.5 comma 0. Straight line over. And the cool part is I don't need, this is construction line, so I can use this snap. I can use, why won't you escape? There we go. I can use the snap to this corner to get the height right, to get a height here. It may not be necessary. In fact, it's probably not. Um, but it is a thing. So, oh, I didn't want to delete it yet. But what I do want is I want to come from here down now because I need to be, as long as I'm inside this, I don't need the square. That's why I did it with the line. I don't need to be inside on both. As long as I'm inside this, the vertical one will be fine. Um, so I can basically start there, go this way, and then come down with the vertical and be absolutely, be absolutely fine. But our duct is an inch wide, so I need to come down from the top here because this is where somebody's going to put their ruler, is this sort of far edge. Come down from the top at 0, comma, minus 0.5, right? That's where it landed. Line here. I'm going to grab that line and come back to my construction line. This point is where that duct is going to start. So if I select this, insert as duct, I need to turn my grid snap off. I'm going to grab that point there. Grab that point there. Now I didn't do it over here. I need to do it on both sides. Come in a half inch, come down an inch, do that. I didn't do it here, but that's okay. But I dropped that in, right? And now what I can do is I can select, just like in SolidWorks, if I drag from the left, I only select the things it touches. So delete those. Those were construction. They don't need to be there. That duct is now in. Now for the vertical run, what I can do is kind of the same thing, a construction line here at 0.50. All right, now it's there. It is in there. I have a line right there, and that's going to be the starting point of the vertical run of duct. Cabinet layout, add duct. Oh, make sure you have your location selected, add duct. Same part number in this case. Now you can mix and match, of course. We can also rotate with the space bar or the icons over here on the left. Rotate it to get it the right way, snap, and just run it down to where it needs to go. Um, and normally I would put both horizontals in first because I like my verticals to be fully enclosed by them. But sort of get the idea. I would enclose this whole thing in a square, knowing that, those are sort of the normal, like that's where my duct is going to be in a square. And then in here is sort of determined by the height of components. So let's, for now, we can do the same thing. Let's add a rail, right? Rails work exactly the same way. And DIN rail is DIN rail. I probably wouldn't use Allen Bradley, honestly, just because of price. But DIN rail is the same way. Like I would normally draw construction lines where I want this to start. For instance, I don't want it to bump right against the duct. I might start it a 1/4 inch in or so. But same difference. Draw constructions to get your starting point, and just sort of slide the thing in and drop it in. Right? It's about that simple. And then when it comes time, now we have a problem. Like, I need to put a PLC in here. But there's no PLC in this list because the PLC is not in the same location. That's a problem. That's a problem. And to fix that problem, we need to go back to our other drawings. So I'm going to close these for now. We need to go back to our schematic drawings. Okay. And effectively, the easiest thing for the PLC, well, actually, we could do it for all. We do it for all. We can blanket it because most of the stuff in this particular project is located on that back panel. Most of the stuff. In some cases, you do not want to do what I'm about to do because it'll blow things up. But in this case, since most of the things are there already, we can just blanket and change the entire drawing. So on main power, I'm going to go to the properties. I'm going to go to the properties and I'm going to change the location, like here, location. I'm going to change it to cabinet backplane. Okay, and then it'll ask me, do I want to change the component or just the drawing? I want to change components too. Okay, I want to change components too. I'm going to do the same thing literally with all of these because most of the stuff, again, most of the stuff is on that backplane. If you get into like the inputs, this prox is somewhere else, and I'll deal with that in a second. But because most of the stuff, it's easier to just change it in all one shot, and then individually in a minute, I will change certain components back. Change component location. Now, if I right click in the properties, maybe not simple properties. Why didn't it change that? Properties. Did I not? Okay. There we go. Okay, that was odd. What I was double checking was if I changed check the symbol properties, now you can see that it updated. So for some reason it didn't take. Maybe I missed an okay somewhere. But same thing, literally all of these schematics I can change now to that backplane. Okay, change components. And backplane there, we're good. Now, I'm not going to do every component, but for instance, this motor is not in the backplane, it's out on our conveyor. I've already created a location for that. So one of the cool things that I can do right on the schematic, I have function. I don't use functions much, but absolutely location outlines. I can draw basically a rectangle around this motor and tell it what location does that rectangle represent. That's the part sort conveyor. I do want to change the components inside it. Okay. And usually, because this is a solid line, and if we print this PDF out black, it might get confusing. Usually, I also dot it. That's a separate thing, way beyond the scope of 2D cabinet layouts. I'm not going to worry about it right now. But it tells me this thing now, I mean, it's pretty clear this is in a different location. This motor is not in the back cabinet, right? The whole drawing is the motor is not. So that is a powerful use of locations. I highly recommend, beyond just the fact that we needed locations to sort of cheat and get more 2D drawings. I highly recommend using locations for things like this, especially in complex and big equipment. Like you can set up, say, a multi robot cell where each robot, the sensors and things that are attached to that robot's area are a location. And it's another way to sort of keep our schematics clear, keep people understanding what we're trying to get at. So it's awesome. I highly recommend using locations beyond just the fact that we need to in order to get our 2D schematics done. So from there, doing the actual, getting the rest of the 2D schematics in is fairly simple. I already demonstrated with the PLC, right? I just, check this 2D symbol and just sort of drop it in here. Try to center. I can't honestly, off the top of my head, remember where the actual DIN rail mount. I think it's centered on this family PLC. So it's just a guess. I mean, as long as it's oriented somewhat close to that DIN rail, it doesn't really matter. Right? Because it's going to snap down. We're going to dimension the DIN rail, and parts are going to snap on the DIN rail. So where the parts actually land kind of don't matter. They're going to snap where they snap. But we'll drop in the I/O cards. That's bugging me. I don't know why those are so big. I am going to, after I finish this recording, go through and try to figure out what is going on with those dimensions. Because it is definitely like double width, and I don't like it. But there, I mean, dropping things in just that fast. Like literally just that fast. So, I mean, things like, I don't know, a lot of these parts I didn't create. I used the downloaded version, so a lot of them probably have generic, but there's power supply, right? You can drop a bunch of, I mean, we could do the entire draw everything that needs to go in here. Now, ordinarily, I would not put the PLC up top. Heat rises. So as things that generate heat are in here, we don't want the PLC eating all that. So the PLC usually in my cabinet layouts, and again, I'm dragging, it's just my laptop being slow. I mean, consider all of the little circles and lines and things that it needs to re-render. It takes it a minute sometimes to move these footprints. Just be patient. I'm still holding the mouse button, by the way, as I'm stalling for time talking to you. It just takes a minute sometimes for it to catch up, especially I'm on a just a standard Dell work laptop. It's not a CAD machine or anything like that. But with a little patience, plus, I mean, a lot of times machine builders are hourly, and the longer I gotta wait for a thing to render, right, the clock's ticking. So, I mean, you would be surprised at the number of billable hours over my career that I have built waiting for things to render like that, waiting for like Rockwell software to download, waiting for all kinds of that, flashing of firmwares and I mean, older FANUC robot controllers even used to take forever to do a USB backup. And guess what? You can't do a whole lot while it's doing the backup. So I may just let go of my mouse button and let it catch up later, but I have a feeling I have now moved it since my hand has been subtly moving. I'm trying to hold still, but it's been subtly moving this whole time. I have a feeling I have moved that PLC way out of the drawing. But we'll see. Hopefully it catches up here in a minute. Because I'm not willing to stall much longer. All right, I'm letting go of the button. Oh, and it's still going to take forever to catch up, and it's not going to let me zoom in or out. Oh, hey, I got my cursor back. Cool. And then it didn't move anything at all. Nice. Thank you. So we're coming up to the end of the video. This is you sort of get the idea. We also, like I had shown before, well, actually, it's still there. I didn't delete it on the main cabinet when I drew these dimensions, right? We wanted to obviously dimension things here. Generally speaking, we want to throw dimensions in, for instance, draw linear dimension to the center of DIN rails and, in logical places where they're going to go, bearing in mind, significant digits and the fact that the guys building these are going to use probably a steel ruler or a square, a steel square. So they're not going to measure 5.79 inches. You can give them 5 3/4, 5.75, sure. So bear that in mind and try to plan dimensions appropriately, or at least significant figures appropriately. Also, a trick to sort of place things correctly would be to place the DIN rail after. So let me show you that because that can be kind of, I'm going to delete the power supply just to get it out of my way. I'm also going to delete these just to hopefully speed up rendering in the future. Alan Bradley, um, in the PLC manual for this, and you're not going to let me drag just, there we go. See, that was much faster. In the manual for this PLC, one of the manuals, they have technical manuals and user manuals and all kinds of manuals. Somewhere in their documentation, you will find keep out distances from ductwork and from other components. Now, other components do not count the I/O cards because the I/O cards have to slide up tight. That's kind of what they do. But it's got keep away distances, minimum distances from other components, including duct. So, construction lines are where it's at when it comes to that. So I need, um, it doesn't matter really where I put the construction line, just not on these tabs, right? Because those are sort of out of the scope. But the main body of the PLC, and honestly, if I remember right, it's been a minute, but if I remember right, Alan Bradley wants something ridiculous like 6 inches. Now they never get it. Not from me anyway. They don't get their 6 inches. They might get four if I can spare it. They usually probably three. But there are defined keep outs, and if you can maintain those keep outs, you should follow the manufacturer's recommendations. So I'm going to set this construction line up 4 inches. I mean, because yeah, look how ridiculously big that is. And I think it's at least 4 that they want. So construction there, the sides are usually a little less. The 4 on the top and bottom for venting purposes. Sides are usually a little less. So just for the sake of demonstration, we'll do 2 at -2, 0. Okay, at -2, 0. So I got those two lines. Now those two lines are actually going to determine for me where this PLC lands. I'm going to select everything, including the lines. I'm going to modify and I'm going to move. And I'm going to move the end of the line. And I can only move, when I use the move command, I can only go side to side or up and down. I cannot go at an angle. It won't let me. So I'm going to snap up to the duct, select it all again, move, and snap this guy to this duct. And that is where that PLC needs to land. That is just where that PLC needs to land. Okay. And actually, I'm not going to delete that construction line just yet because I want to use it now. That's now going to be the basis. Since this is dictating where the PLC needs to be, the PLC is now dictating where the DIN rail needs to be. So I'm going to create another construction line on top of this one. And like I said, I usually space my DIN rail a ½ inch, ¼ inch out. So let's do a half, 0.50. Okay, I now have a line there. I can delete the original, the PLC line. This is where my DIN rail needs to start in order to get the PLC in the right spot. So now I can come back to, am I in the right location? I am, I hope. There's the DIN rail. Insert as rail, select, and again, drag it to the length it needs to be. And I don't know what length it needs to be, probably in here somewhere, right? All right, I can get rid of that construction line now. Now is where that whole move above, move below thing really comes in handy because the DIN rail obviously is not going to show up above the parts. So I can right click on it. Or I'm sorry, it's not right click. It's a cabinet layout order. Move below and then select the PLC and it pops down. Okay. If I had a whole bunch of stuff, I could also select all of them at once and say move above the DIN rail to pop them all at the same time. So I don't have to do it individually. But that is how we maintain those required clearances. Also on terminal blocks, which I'm about to talk about in depth. As I said, I was going to end this video like 20 minutes ago. As we do terminal blocks, I try to maintain at least 1.5 inches. We need some room to get the wires room to bend, and honestly, to get my fat digits in there to wire them in the first place. So I try to leave at least 1.5 inches for terminal blocks. They usually don't have a required clearance because they're not generating heat. I try to shoot for 1.5 inches. That seems to work out for a nice, good distance where I can actually get in and you can do some work. Terminal blocks are a thing, though, that I do want to talk about. Now, this project, as it sits right now, doesn't have any. I'm going to drop some in just so we can talk about it. So terminal strips, I'm going to create, and actually I'm going to put them in the backplane because that's where they're going to be. A new terminal strip, X1's fine, automatic's fine. We'll call it main, I don't know, let's call it IO distribution, I guess. Okay. I'm just going to create terminal strips. Number of terminals. No, I can't define that. That comes in a minute. All right. Open it up. Okay. Insert several terminals. I want to insert 20. I'm making this up. This is for demonstration. I am going to add a manufacturer part. I am. Assign a manufacturer part. And I'm going to go down to Weidmuller because I created at least one, I think, for a different. Was it that one? I think it was that one. All right, I'm going to select that. It wasn't that one because I had a 3 terminal, but this will work. All right, so I got a terminal strip in there with 20 terminals now. Cool part about insertion here is insertion of terminal strips is entirely automatic. I do not have to insert 20 terminals. I can do terminal strips. Oh, I'm on the wrong tab. Wrong tab. Terminal strip, though, it shows up over here now. Right? Shows up over here. I could insert all 20 of them individually. Or on the cabinet layout, I can insert terminal strip. It pops up here, select this one, figure out where I want to put it. So I want it on a DIN rail, right? Drop it, and it is going to drop in all 20 of them. Yay! Yay! Right? All 20 of them. So terminal strips are awesome doing it this way. Things like output fuses also can be done this way if they're set up as terminal blocks. All kinds of cool stuff that can be sort of automatically done. But that is about it. I mean, the last thing I would do, like straight up the last thing, is I would select it all, do a modify, or not a modify, I'm sorry, not a modify. I'm going to change the sheet scale. I'm still thinking in drawing terms. We're in the cabinet backplane, properties, change the scale. Let's start with 1 to 4 and see what it looks like. We do need to be a little careful. We do need to be a little careful to make sure that things are still legible. But again, if this, I think, was just because I labeled it too small. Either that or Alan Bradley did. I think Alan Bradley actually, when I imported, brought this symbol in. I don't remember creating. I created the I/O cards in a video. I don't remember creating the PLC. But so that's sort of the last step. There would be, of course, be dimensions in here because we already created them in the one-to-one view. But yeah, that's sort of the last step on this drawing. Now we've got things all out of whack because these cabinet layouts got added to the end. I deleted a few. Numbering is out of order. So from an overall, so the 2D layout would be done once everything is in place. And of course, things like proc switches that are out of the machine don't go in a 2D layout, right? So we're done here. But from a sort of complete project perspective, the next thing to do would be to renumber the documents. We want to renumber everything just to get our documents in the right order. Okay. And then finally, we can go back to our reports, generate our drawings. I'm going to leave remember, this was the original. This was the original BOM. I want to leave that turned off because I'm now using my filtered version. I'm going to update the drawing list in the bill of materials, and we should be good. We should be good. Close, close. Let's check the bill of materials and really just the second page. Saginaw controls, I have an enclosure, a backplate, one of each, right? And I've also got now 20 terminal strips because I dropped them on that 2D footprint. Now we are complete. And if I go back to my drawing list, everybody should be in order. Everybody should be happy. Yeah, 10 drawings, cool. So now we are complete. I'm going to call the video there. Hopefully that was helpful. Hopefully that gives you a head start on creating accurate 2D footprints in SOLIDWORKS Electrical. Thank you for watching. It's been a pleasure, and I look forward to seeing you in the next one.